Good evening, sir.
Yeah. So, can we get started? Yeah, you can unmute and ask your doubts.
Hello, sir. Good evening, sir.
Good evening.
Am I audible, sir? This is
Yes,
the
yes.
yes, sir. This is the Satyavir Singh from Tata Projects Limited. Sir, I missed at the assessment from due to my health issue. So, may you suggest, sir, what should I do for that, sir?
You missed what? I'm sorry.
I missed at the assessment for submission, sir.
Assignment, you mean?
Yes, sir.
Oh, okay.
I returned mail, but I did not receive any mail from your side, sir.
No, but I see. I'm not. See, operation of the course is being done with the NPTEL office. If you can reach out to them directly, it may be helpful. Yeah. Can you? Yeah. See, there's a thing there. Support at nptel.iitm.ac.in. If you can send email to that address, you see in the chat box.
Sir.
Yeah.
Sir, also, I guess only the 8 assignments will be considered for the evaluation.
Okay.
So
not
even
all
if
of them.
not all of them. So best 8 will be considered. So even if one is missed, it's okay.
Yeah. Okay.
Okay, sir. So there is no issue, sir, then?
No, there's no issue. No, not a problem.
Oh, thank you.
Okay, sure. Okay, there's a question in the chat forum. Okay, Anupama, you posted from the discussion forum. Okay, why yield stress increases with increase in water binder ratio? I'm not sure where you got that from. Oh, yield stress. You're talking about rheology. No, increase in water binder ratio, you'll have more water present. So the spacing between your solid particles will go up. That means your yield stress will decrease, not increase. It's the opposite of what has been stated here. Yield stress will decrease with increase in water cement ratio. I'm not able to open this spreadsheet with the questions. Can Anupama, you have it open? Were there any questions on the spreadsheet?
There is not much questions in the discussion forum, sir.
Okay, no, not the discussion forum, the spreadsheet that was shared with the live class link.
Sir, there are no queries. No queries.
Okay, fine. Okay. Yeah, anyway, the people who have joined today, kindly let me know if you have any specific questions with respect to the content of the course, because your exam is coming up at 28th, right? So I hope that all of you will be taking up the exam, and if you have specific questions with respect to the content of the course leading to the exam, please do raise them now. Discussion forum also, there's only one question.
Sir, good evening.
Yeah, Nirmalendu, please go ahead.
Sir, when we will come to know the exact location center for exam?
Okay, again, you asked me a question which is out of syllabus for me, because the NPTEL team will be able to answer that better. I'm not quite sure myself how the scheduling works and when you actually get the intimation with respect to the location. See, 28th is the exam. So I believe at least 2 weeks before that, or by the end of this week, you should be getting a notification, I think.
Right, sir. Sir, I have one question regarding high strength concrete.
Yeah.
Because I'm working in Prism Johnson Limited, RMC unit. We are actually designing M80 grades concrete.
Okay.
So what we observed, we are using best quality OPC 53 grade cement here.
Okay.
That is called Wonder 53.
Right.
And fly ash is from Dadri source.
Okay.
And microfines we are using ultra fine GGBS.
Okay.
So we are getting 7 days strength is tremendously high. In M80, we have got 87, 88 MPa.
Okay.
But when we go for 14 days and 28 days, it is not increasing further, sir.
Okay.
Sir, why it is happening? Is there any temperature effect or is there any something? Can you please guide?
Yeah, not really temperature. See, you're basically speeding up your reaction significantly. I think you must have used a very high cementitious content and low water to cement ratio.
Yeah,
Right.
low water cement ratio. We have our water powder ratio is around 0.22.
See, 0.22. It's a very low water powder ratio. And you must have used, I guess, 600 kilograms or something of total cementitious content, right?
It is more than that, sir. 714 is
Wow.
total.
700 plus. Okay.
714.
Okay. This is including cement, slag, and silica fume.
Cement fly ash as well as microfines. Alkofine 1203.
Cement fly ash and alkofine. Okay. So, yeah, see, you've worked out a mixed design, which is having a very high cementitious materials content that leads to a large amount of fine powder in your system. So you're basically filling up your volume very efficiently. Okay. So your water is very less. And
Okay,
as we know that water cement ratio, which is of this low level, 0.22, will not lead to water availability for complete hydration. So only partial hydration will take place. Secondly, because the water is so less, there is no space available for hydration to continue. Okay.
Gel space ratio.
Yeah, your gel space ratio is basically close to 1. That means your entire space is filled up with the gel already by 7 days. You don't have additional space for growth of hydration products to happen. And when you don't have space anymore, hydration starts getting limited. It will not proceed in a big way. So what will happen is because you've lowered water cement ratio and upped the cementitious so much, you really don't have too much space available in your system for extended hydration to take place.
So should I reduce our cementitious content? Automatically, the water powder ratio will be little bit of increased without changing the water content, free water content.
So if you are able to get the strength and workability parameters at lower cementitious content, that is most ideal and optimal. But if your design has been worked out after a significant amount of trials to get to this level, stick with it. There's no issues, except that make sure that because of this extremely high cementitious content, you're not getting any cracking, thermal cracking, because this is a very high cement content.
Right, sir.
But otherwise, the hydration is not really happening too much beyond 7 days. That's the reason your strength is not getting further increased too much. But anyway, you're meeting your requirements, so there is no real problem.
Thank you, sir. Sir, I have another question. So it is out of track a little bit.
Yeah.
Actually, I have missed 4 internal assessment.
Okay.
I think it is 5 to 8, which is mineral admixture part. So is there anything to do more?
No, as Anupama had stated, there are 12 total assessments, out of which you need to at least have 8. The best 8 will be considered. So as long as you have 8, don't worry. Okay.
Definitely, the first 4 is completed, and the week 12 is only pending with me.
Okay.
9, 10, and 11 is completed.
That's good.
So within these all these 8 will serve the purpose, sir?
Yeah, that's what Anupama, that's correct, right? Only 8 are considered for grading.
Okay, sir.
Yes, sir. Yes.
Okay. Good.
Thank you, sir. Thank you.
Sure.
Sir, there are some queries regarding using quartz powder in UHPC mix.
Yeah.
I'll just post it in the chat.
Why is quartz powder not used to maximize reactivity in UHPC mix? What is heat treatment? No, quartz powder, see, quartz is an inert material. So quartz powder will only get reactive if you crush it down to a very fine size. Okay. Now, yeah, what you've written in the next line is correct. Quartz influences reactivity by acting as a site for hydration. during initial stages, because quartz is a very fine material. Like when it's ground as a fine powder and used in concrete, it will act as a site on which hydration can actually take place. So that aspect of quartz powder is important to consider. And based on that, yes, early age reactivity can get enhanced with quartz powder, but also when you do heat treatment, that means during the curing process, if you take the temperatures up to 60 to 80 Celsius, there is an opportunity. There's only a small chance of that happening, but there's also an opportunity that some of this fine quartz powder may also react, but that also depends on the kind of silica that is there. Mostly quartz powder will have crystalline silica and will not show any reaction. Mostly it will behave in this fashion, as you've rightly stated, as a filler. It acts as sites for hydration products to go around. As a result, it enhances the early age hydration characteristics. Could you please explain which is the better option to use quartz powder and UHPC, whether to mix with cement or with fine aggregate? Also, please explain whether addition of nanosilica in UHPC has any effect like increase or no change in strength when subjected to hot curing. Again, all that using nanosilica in UHPC, it's all based on experience that people have had, right? Whenever you use any nanomaterial in concrete, the challenge is how do we disperse it? How well can you disperse the nanomaterial? Because unless you disperse it very well, first of all, it will not be able to, it will be starting to agglomerate if you don't disperse it well. If it agglomerates, then it's not a nanomaterial anymore. To make it function like a nanomaterial, you need to ensure that you disperse it well. It should go and occupy the spaces available in your system and ensure that also it creates additional enhancement in hydration, and nanosilica obviously will be reactive on its own because it will react with lime to produce CSH, right? So now the first part is how to mix the quartz powder, whether as a part of cement or as a part of the aggregate. See, generally, general guideline is if your size of the powder is less than 125 microns, or let's say even 100 microns, if the size is less than that, you consider that to be a part of your cement. If it's more than that, if it has a size range which is even beyond that, then you can consider it to be part of your fine aggregate. Okay, but then again, your ultimate idea is to produce a composite that is having the required properties. So you can consider it either way. But please remember, when you're considering it as part of cement, then you have to look at how to design the superplasticizer content and type for achieving the required workability of the mix. Even after achieving good density, packing density using quartz powder, how does water penetrate through pores? Now, see, water penetration from external environment will obviously reduce significantly when you have a well-packed concrete. But internally, water has an opportunity to move because capillary porosity is connected, and this connected porosity basically causes the water to move around. The more porosity gets disconnected, right? That's when the water cannot move around easily. CSH gel is not hydrophobic. Okay. The pores in CSH can soak up water. So it is, hydrophilicity is true of all cementitious materials. They are not hydrophobic at all. Magureshwaran has said that in these lectures, we have seen blended cement with OPC, but we have access with PPC. Can we use cementitious material PPC? If so, how can we add cementitious material as there is already 30% fly ash present? Yeah, so in PPC, already 25 to 30% is fly ash. So adding fly ash to PPC, unless you want a combination that has overall 40 to 50% fly ash, you would not be doing that. But you can certainly mix PPC with metakaolin, PPC with silica fume, or PPC with slag to get different types of effects. You may want a high strength mix when you use PPC with silica fume. You may want a low heat mix when you mix PPC with slag, and so on. So it depends on the application that you really want.
Hello.
Yeah. Yes.
Sir, in crust sand, we get some percentage of particles lesser than 75 micron.
Yes.
So will it be considered under powder content?
No. See, overall, crushed sand still has a particle size distribution that starts from 4.75 all the way up to less than 75 micron. So It is still considered as aggregate only. It's just that this fine powder may also interfere with the cementitious system. That's okay. But if you are necessarily adding a powder which is entirely below 100 micron, then it's better to consider that as part of your cement paste when you do your design. That's all. Okay. Question in the chat box: when we increase temperature of water curing, purpose of cubes, what will be the effect on strength? When you increase the curing temperature of the water, what will be the increase effect on strength? Yes, strength will go up as you increase the water temperature for curing. Okay, strength will go up. However, you have to remember, if you have very high temperatures in the beginning, while your early strengths will be very good, your later age strengths may not compare as well with normally cured concrete. There's sufficient research to show that your later age strength, 28 days and beyond, the strength is not as good as concrete that is cured normally. So you can do hot water curing if you want very early strength, but you have to remember that on a comparative basis, you may not get the same 28-day strength.
Sir,
Sir,
in
Nirmal-
Yeah, go ahead, Abu Bakar. Abu Bakar, please go ahead. Okay, Nirmalendu?
Yes, sir. My question is about mass concrete, what you taught us, sir. You told that the basic general guideline of the core temperature should not exceed 70 degrees centigrade.
Yeah.
And that also depends upon what is our pouring temperature of concrete, as well as what is the L/H ratio, and then of the structure, as well as what type of cement, what type of aggregate, what type of mineral admixture we have used.
Yeah.
So when we are adding supplementary cementing material, SCM.
Yeah.
So you also told that this 70 degree can be increased.
Yeah.
Because in more than 70 degree, even we have used SCM in a good proportion, that even more than 70 degree, DEF is not produced. So what is the reasons behind it, sir?
Okay. Now, generally, see, the 70 degrees as such is anyway a very conservative requirement. But then again, in structural engineering, we want to be as conservative as possible, right? Now, that 70 degrees was arrived at based on some results from laboratory studies, which showed that when cementitious composites are exposed to very high temperatures in the beginning, right? And there is sufficient access to moisture, DEF can be a problem. Okay. Now, when you replace cement with mineral additives, first of all, you are reducing the alumina content of your system, or rather the, let's say, if you're using a siliceous admixture like fly ash or something, your overall C3A content is getting reduced. When C3A gets reduced, your potential to form ettringite, okay, also is getting reduced. Okay. Now, secondly, most of these mineral additive based systems result in concrete that is impermeable. It is having reduced permeability as compared to plain Portland cement concrete. So one essential condition for DEF to happen
Moisture
is moisture. Yes.
Right.
Correct.
I got your
And
point.
what has also been observed is that another condition where DEF can happen is in the presence of large alkali content, sodium, potassium, and so on. So whenever you use mineral admixtures, you are automatically cutting down the alkali content, right? Because these don't add to the alkali loading of the cementitious material. So all of these conditions act favorably in reducing the potential for DEF to happen in concretes with blended cements. So that's why you can even, I mean, there's some research work that is available. There is no standardized number in any of the codes, because everybody will obviously adopt only a conservative number like 70 degrees Celsius, irrespective of the type of cement. But you can see some evidence in literature, research-based evidence, as well as case studies from sites where concrete with mineral admixtures, even when temperatures have gone to 85, 90 degrees Celsius in the concrete, it has not led to DEF related problems in the long run.
Sir, actually, as far as alkali content is concerned, sir, we also know that in fly ash, as per IS 38, what is the code actually?
3812. Yeah.
3812 part 1. And it is saying that the maximum alkali content it is around 1.5%. But
Correct.
our cement is 0.6 to 0.8%,
Correct.
Indian cement conditions, right, sir? So in that case, when we are replacing certain percentage of cement,
Yeah.
so is it not increasing the alkali content?
Yeah.
Because
See, the alkali load that is brought in by the metal admixture may be high, but what happens to this alkali is that it is getting immobilized in the structure of your siliceous glass that is there in your mineral admixtures.
so it is trapped over there.
It's trapped. The alkali is not free to come out and interact with the aggregate to produce alkali-aggregate reaction or to increase the overall alkali content of your pore solution. If you look at your pore solution composition, the alkali content will be lowered whenever cement is replaced by any mineral additive.
Right, sir. Thank you.
This is the reason why mineral additives also work better against alkali-aggregate reaction. Okay. The same concept holds because alkalis are not freely available.
Yes, sir. Can we actually, in case of, if we go with mass concrete with M80, M70, once it is mass concrete as well as it is high strength concrete.
Okay.
So in that cases, we are using microfines like micro silica and ultrafine GGBs or something like that.
Right.
In which the reactivity is very high, the heat of hydration, although the cement content is less, because we are replacing cement with this.
Correct.
So is there any, because the heat of hydration will be very high in that cases.
Yes.
But it is also a mass concrete. In that case, how do we cope up all these two things?
Yeah, see, that's why. So first of all, in most mass concrete applications, like for foundations, etc., we have to work with as low a concrete strength as possible. It's better to work with M35, M40 concrete when we are talking about foundation type mass concrete structures. Now, in certain cases, when you're doing high-rise buildings, you may have to use the shear walls, which have high strength concrete and also are mass concrete because most shear walls are more than 1.52 meters thick, right? So in such cases, you have the problem because you have to attain strength, durability, and ensure that your temperatures inside are also controlled to a large extent. So for that, of course, you need to start looking at minimizing placement temperature. Lower placement temperature will lead to lesser maximum heat inside the system. So whenever you're using mass concrete that is also high strength, you need to ensure that you can minimize the placement temperature to as low as possible.
As well as, sir, we can also increase PFA also.
Yeah, PFA increase is possible, but once again, when you increase PFA or pulverized fuel ash, you should be ready to accept 56 days strength results.
Yes, sir. Yes, sir. Yes, sir. I
If
agree.
we still insist on 28 days, then we'll have a problem.
Yes, yes, sir. Yes, yes. Thank you, sir. Thank you.
Thank you. Yeah, so, the question in the chat box, can you elaborate on the sensors used for foundation concrete in Telangana when we did the mass concreting in Andhra, not Telangana, we did this in Amaravati. So in this case, the raft was nearly 4 meters in depth. The sensor was nothing but a thermocouple. The thermocouple was used to monitor the temperature of the concrete in the different regions of this foundation. That's all. So there were no special sensors. It was just a thermocouple. You can also, today, there are also these, they're called smart temperature tags, which you can just fix along with the steel at different locations. You don't even need to have a wire coming out of it. Okay, all you have to do is activate one app on your mobile, which works on RFID detection. And this RFID is able to read out from within the foundation the temperature of the concrete at different locations based on the sensors that you put in. So these are called smart tags or smart temperature sensors that you put inside the concrete. If we increase mineral admixture in concrete like silica fume, then what will be the effect of durability of structure? Now again, please remember, whenever you use any mineral admixture as a substitute of cement and ensure that you're doing a proper curing, the effect on durability is always positive. You always get better durability because your permeability is lowered. So your durability automatically gets enhanced when you replace cement by any mineral additive and also follow it up with a proper concrete construction strategy, including curing. Okay. There's a hand raised, but of course it's a mobile name, Realme 6i. Yeah. Can you please unmute and ask a question? If you have not unmuted, please unmute and then ask your question.
So the hand raise might be by mistake, I think.
Okay, okay. You had a question, Abu Bakr. You previously had said something.
Yeah, yes,
Yeah.
sir. Sir, I was asking, suppose we are doing a mass concrete in which the temperature of the core is about 70-80, and on the top surface, it has gained the ambient temperature of 30 or 35 or something. So, in that case, instead of placing that, you said thermocol, if we do curing by hot water, is that a good practice?
Hot water. Okay.
To maintain that 20 degrees Celsius difference.
Yeah, but then, yeah, I mean, it's been attempted. Yes, people have also done this with hot water. Only thing is, how do you continue to maintain water at that temperature? Using thermocol, you can maintain the temperature of the top fairly easily. But when you use just hot water, how do you maintain the same temperature of the water? Because water will also slowly cool down.
Yes, sir, it is difficult. I was just asking for the, is it a possibility?
Yeah, I mean, it's possible, but it's not a solution that has been.
It's not feasible. It's not feasible.
Yeah, it's not been done on site much using hot water for curing. Yes. Because again, you have to monitor that and maintain it also.
Yes, definitely. Sir, I have one more question. Can you please elaborate on guidelines regarding redosing of admixture when we order from RMC?
Okay.
Because we don't know whether before reaching they have added some admixture or not. How can we adjust that? The maximum limit.
So redosing, correct. Redosing is not something that should be done everywhere. Okay. It's only in specialized applications where you have the full support of the construction chemical manufacturer who knows what is the strategy of dosing when you are experiencing rapid slump loss. Okay. So in such instances, redosing can be done. But please remember, there is always a maximum level of additive that should be permitted in your system. You should take care that the admixture content does not increase beyond that level. So when you redose also, you have to redose in such a way that a part of the actual permitted amount is being added at a later stage. But all this should have been worked out with appropriate trial mixes to establish what is happening here. I think that's important that all of these aspects that you're trying out on the site have some reasonable understanding to make that judgment. So first of all, as I said, you need to have a proper support from the construction chemical manufacturer to ensure that you're not putting more than a certain critical level of dosage, because as we discussed in the course lectures, you will lead to an excessive retardation. You may not have concrete setting for a very long time if you have too much admixture dosage and so on. So all that has to be properly sorted out. And secondly, prior understanding and experience through appropriate trial mixtures could be useful to figure out what would be the strategy. So we had done this on one of the projects in which I was consulting for the contractor who was executing the project, high strength concrete project, where the concrete was experiencing severe slump loss when the design had full admixture added in the beginning itself. Then they later shifted to 80-20 dosing. That means 80% at the plant and remaining 20% after the truck came to the site. And that seemed to actually help them control the slump loss to within about 10 to 15 millimeters. So that was very useful for them. But that's something which was worked out after some understanding and trials.
Okay, sir. Thank you.
Yeah. So I guess the hand raised from Realme 6i was with respect to assignment submission. Again, as I said, there's no extension, but you don't have to submit all 12 assignments, or you should submit all 12, but if you have not done it by mistake, it's not really an issue. Only the best 8 will be considered. So that's okay. If you have not been able to submit 1 or 2, it's okay. Right? Anupama has given a question on the discussion forum: is if SSA, specific surface area of cement, has to be evaluated by BET, will it produce the same result as Blaine surface area? No, it will not. It will not produce the same result. BET is based on nitrogen adsorption on the surfaces of the particles. You will get a much more accurate result with BET as compared to what you get with Blaine specific surface area. You will generally get a higher surface area from BET as compared to Blaine. Other than temperature monitoring, generally considering concrete, can you give an idea on concrete monitoring system, structural monitoring system? Now, structural monitoring, of course, can be done by affixing strain gauges and affixing deflection gauges at different locations. Or you can have fiber optic sensors embedded within the concrete also. And you only have to ensure that you are getting that data and making some sense out of it. There's no point in just putting sensors inside and forgetting about it, right? In agro-based mineral additives, you had mentioned when rice husk is burnt at elevated temperatures, K2O melts and unburned carbon is captured, leading to high LOI retention. Does this apply to other agro-based ashes such as SCBA? Again, this was specific to a particular research study that was being done. I'm not fully aware whether the melting alkali is able to completely capture the unburned carbon. But again, this could happen in other ashes also, in my opinion. I didn't submit any out of 10. Now that is not, yeah, Realme 6i, but you have 12 assignments. If you're taking the course seriously, you should have submitted something on time. So I don't think anything can be done at this stage for that, unfortunately. Yeah. Kumar has a question. Can you please explain about lightweight concrete using EPS beads or thermocol balls? Advantages, disadvantages, applications. Possible to get more strength by adding some fibers. That should be lightweight and useful for structural purposes. Also, explain about fly ash-based aggregate. Which alkali solution is more effective for cold bonding or sintering? Now, of course, EPS or thermocol balls are basically a lightweight aggregate that can be added to the concrete, but it will lead to obviously a very weak matrix. So it is not intended for high strength applications anyway. It is intended mainly for lightweight applications such as insulation. So you have to look at the application carefully before you design the concrete. There's no point in using fibers unless you want to improve the crack resistance capacity, because this is not structural concrete that you'll produce with thermocol. You may not get structural level concrete. So you may have to actually use it for insulation purposes. And their fibers may not be useful unless you're having a problem of early age cracking in your system. Fly ash-based aggregate, again, as you rightly said, you form it either by cold bonding or sintering. For cold bonding, typically the curing is done in water itself, or you can use calcium hydroxide solution if necessary, but it's usually done in water. Okay. For sintering, you don't have an alkali solution. You basically use a cementing material to fuse the particles together, or to stick the particles together to form the pellet, and then you sinter it. Nirmal, do you have your hand raised?
Yes, sir. Actually, lightweight structural concrete. You also told in the video that coal bonded fly ash aggregate is best. And
lightweight structural concrete is, but not EPS. EPS
has EPS. I'm talking about coal bonded fly ash.
Yeah, cold bonded fly ash aggregate can be used for structural concrete. No problem.
Structural concrete.
But
so what is the
cold bonded fly ash aggregate may not be as lightweight as sintered aggregate.
Okay. So
may
what is
not
the
be very
specific
lightweight.
gravity, sir? What is the specific gravity of cold bond fly
The
ash?
cold bonded fly ash aggregate will have a SG of nearly 1.8 to 2. So it may not be very lightweight.
And sintered fly ash?
Sintered will be less than 1.3. I'm not very sure about the correct number, but because a lot of porosity is there in the system in sintered aggregate as compared to cold bonded.
Right, sir. But as per strength, which one is better?
The
Cold
strength
bond
will be
or
better for the denser the aggregate, the better the strength.
the cold bond is the better?
Yeah.
And
Strength
out of
increase
F
with
fly
increasing
ash,
density.
and out of class F and class C fly ash, if we go with class C, it will be better than class F, no, sir?
Yeah, class C is because you have calcium present in excess, you can go for cold bonding directly. Whereas class F, you have to go for sintering.
Okay. And sir, one question more. I have one question. When we are using microsilica powder, just like Alkane or something like, and when we are using nanosilica, so the particle size of the Alkane is around 0.15 micro. Sir, could you please tell me what is the average particle size of this nanosilica?
Yeah, see, nanosilica, although we call it nano size, it doesn't have to be a few nanometers. Typically, even a few tens of nanometers is okay. 50 to 100 nanometers would be the more appropriate size. Sometimes we may also have particles that are less than 50 nanometers. But see, again, since the particles are so small, dispersion of these particles can be very problematic. So microsilica has particle sizes of 150 microns. 0.15 micron.
0.15
or 150 nanometer.
150 nanometer.
Yeah, so it's a double or triple or maybe sometimes 10 times the size of the nanosilica. So although we call microsilica and nanosilica, the actual size difference is only about 10 times. That's all. It's not 1,000 times.
Sir, what is the difference between the CSH produced with normal microsilica as well as nano microsilica? Are they going for...
CSH is just produced because of the reaction of silica with calcium hydroxide. You will get a similar characteristic. It's not going to be all that different. Although I don't know, I've not myself come across a direct comparison of the CSH nature. But in terms of the reaction, there's not going to be too much difference. Of course, if the nanomaterial has been dispersed properly, it will have a much faster reaction as compared to microsilica.
Is there any pore refinement and grain refinement difference between these two?
Well, again, see, the reason why the extent of refinement expected with nanomaterials is not always seen in research studies is because we have not had a successful dispersion of these materials. If you can do a study in which this material can be dispersed absolutely properly, then I'm sure that the nanomaterial will provide a better space filling as compared to the micromaterial. But please remember, in concrete, it's not just the question of finding the finest material. You have to find a range of finenesses that go from coarse to fine to really fill up the entire composite volume.
Particle packing.
Yeah, exactly.
Right. Thank you.
If there's delay in setting of newly laid slab because of loss of moisture from the top surface of concrete, beneath layer of concrete is still wet, what should one do to speed up the reaction so that beneath layer concrete also sets fast? Okay, you're saying that the top of the moisture surface is drying off and layer underneath is still wet. But that's not because of hydration, no? The hydration of the top and the middle or bottom of the concrete should happen at the same speed. It is only the drying of the top surface that is happening. So all you need to ensure is that the entire concrete basically gets hardened similarly. So you need to start protecting the top surface and prevent drying from happening. Okay.
Sir, I have a question.
Yeah.
Sir, what are considered alkalis, like it is sodium oxide and potassium oxide, or the unhydrated calcium hydroxide also is considered alkali?
No. First of all, calcium hydroxide is hydrated, not unhydrated. Calcium oxide is unhydrated.
Oh, yeah, calcium.
Yeah. Calcium hydroxide that is present in cement after hydration it is a hydrated material. It's an alkaline material, but when we say alkalize, we basically refer to sodium and potassium.
Okay, sir.
Calcium is also an alkaline material, but sodium
Yes,
and
it is
potassium are
alkaline
primarily
earth
considered
metal.
alkalis. Yeah.
Yes, sir.
Sir, I have one question more, sir.
Yeah, go ahead.
Sir, actually what we have found that when we are designing, suppose a normal grade of M25.
Yeah.
I have analyzed that the paste content is around, paste content means cement plus fly ash plus free water.
Yeah.
This is around 26%, right,
Okay.
sir? If we go with a high flow concrete,
Yeah.
25 not normal, I want at least 650 slump flow after 3 hours.
Yeah.
So what percentage of paste should be increased from the normal paste percentage? It is 26%. Should I go with 33% or 35%? Any thumb rule is there?
There's no thumb rule, but if you, I don't know if you saw the lecture on self-compacting concrete in the course, there was a similar exercise undertaken by one of my PhD students at that time who did this work. And he was able to figure out that once you take the aggregates in your system and calculate the void content that is left behind after optimal particle packing, the amount of paste required is a little bit in excess of that. And we established this for most self-compacting concretes that the amount of paste required is about 60 liters per cubic meter in excess of the void volume in liters per cubic meter that is available in the system. Okay. So if you can just see those notes, you'll be able to figure out how to produce self-compacting concrete. I mean, with that same approach, it's not the approach that will work in all situations, but it'll give you a good handle on how to design your mix and decide on at least an initial formulation with the correct paste content.
Sir, when we are increasing paste content,
yeah,
with same water cement ratio, suppose in case of M25 normal mix, suppose my water cement ratio is 0.47, right? So keeping the 0.47 water cement ratio constant,
yeah,
we are increasing powder part as well as water part.
Yeah.
For making it, because we are increasing paste content.
Correct.
But we are simultaneously we are reducing aggregate part also.
Correct.
Sand and aggregate. So aggregate cement ratio will be decreased when we are transferring from normal to high flow mix.
Correct.
Right, sir. Sir, we have seen that even the water cement ratio 0.47, but we are getting lesser strength in case of high flow mix.
Yeah, see,
so is it because of aggregate cement?
See, when you want to make a concrete mix self-compacting, it is very tricky to work with high water cement ratios. Generally, self-compacting concrete is better made when you have water cement ratios of the order of 0.4 and below. If you work with more than 0.4, making a mix high self-compacting becomes very difficult because you don't have sufficient fines in the system to really get you that self-compactability, right? Okay. So as a result, you have to ensure that you're doing an appropriate design. So SCC mixes for low grades of concrete may not be easy to achieve. Huh? That's something which you have to work with a lot of trials to really get it done. So, but read that chapter, you will be able to see the calculation. There's also a paper published by the same person in Indian Concrete Journal, which talks about how much paste you require in addition to the void space that is left behind to actually get self-compactability. And that can help you actually calculate that. So please remember, in the approach that was done in the formulation, the void content was determined by a certain amount of aggregate and more paste was used. So paste to aggregate ratio is changing to make it self-compactable.
Right.
So,
sir, in case of autogenous shrinkage with low strength concrete, high strength concrete, where water cement ratio is below 0.4. So in that case, what is the remedy, sir? How can we avoid this autogenous shrinkage?
Okay, so autogenous
suppose M80, M90 grades.
Yeah, it's a problem with very high grades of concrete. In such instances, what has been seen is that if you prevent drying of the system early stages. Now, I know that autogenous shrinkage is related to moisture movement within the concrete, but if you keep the environment moist, the tendency for the water to move around is reduced to a large extent, because there's external water that is available in the initial stages of curing, right? That helps to lower the strains caused by autogenous shrinkage. So if you see that if you expose concrete after 1 day versus you cure for 28 days and then expose it, water cure for 28 days and expose it, you'll find that the internal strains due to autogenous shrinkage get reduced when you do wet curing. So wet curing is the best option for reducing autogenous shrinkage, extent of autogenous shrinkage.
The steel fiber will work on that?
No, so steel fiber cannot reduce shrinkage. It can reduce potential for cracking. That's all.
Okay.
Steel fiber itself will not reduce shrinkage.
No, whatever steel fiber we are using, this copper coated, 13 mm and 0.2 mm. If we use the M90 grades concrete, does it help to reduce autogenous shrinkage?
As I said, steel fiber will restrain or rather lead to a reduction in the crack formation. But it will not reduce the autogenous shrinkage.
It will happen.
Autogenous shrinkage will happen because the
propagation of crack will be slowed down.
Correct.
Right. Thank you.
Yeah. There's question in the chat box. Is it possible to produce artificial aggregate by using GGBS? Again, see, you can produce a geopolymer as an aggregate. You can pelletize a slag with alkaline material and then use it as a geopolymer based aggregate. It's also possible. People have also directly ground granulated blast furnace slag to aggregate size and used it. In Karnataka, there are a few experiments that have been done like that. Only problem with that is your silica is still reactive in this system. So you have to be a little bit careful about the impact it may have on the stability, alkali-silica reactivity, that is. So that's the only thing you need to worry about. In this course, alkali-activated cements or binders were not discussed. Please give a brief on AAB and its potential to be alternative binder to OPC. This is a fairly big question to answer here. Yeah, I know the course was only of a limited duration. I could not discuss all possible types of special concrete. But yeah, alkali-activated binders were discussed to some extent when we talked about the hydration of slag, right? So slag hydration, as I said earlier, can be activated by alkalis. And this alkali activation leads to the hydration of slag. So it does not produce the aluminosilicate type polymers, which you see with fly ash, which is alkali activated. With slag, basically, alkali activation enhances the hydration of slag. So that's an alkali activated slag material. But with fly ash and with calcined clay, the use of alkaline solutions leads to the dissolution of the silica and alumina and reprecipitation in a three-dimensional network, which we call as geopolymer. Now, again, there's a lot of literature on this. You can definitely look at the range of literature and then read on your own. I think that would be the best way forward. At which phase of mixing do we need to add admixture? When we do concrete without use of mixture machine or RMC, how can we add admixture? Okay. See, to have an admixture to be effective, you have to do a machine mixing of concrete. You cannot do a hand mix and ensure a proper distribution of the admixture or the right level of performance with it. So again, I would really urge everybody not to do a volumetric concrete, not to do a hand mix concrete, unless it's for a very low low grade type of an application. Okay. Even there, M5, M10 mixes also can be designed and done. It's weight batching design can be done. So I would not use admixture in cases of volumetric design and hand mixing. At which phase of mixing should we add? I mean, that depends on the type of admixture. As I said earlier, when you use SNF superplasticizers, it's better to actually add a little bit after the water has already come in contact with the cement. But in most other cases, you'll be mixing it with the water and dispensing it into the mixer. Air entrainers you'll get some advantage of producing these air bubbles when you mix it along with the dry aggregates in the system itself. But that depends entirely on how your batching plant actually works. In most cases, along with the water, you'll be dispensing the admixture also. If in case of slump increase more with use of admixture, is there any remedy without adding additional cement? Well, your slump requirement on site is a minimum slump requirement. If you have a higher slump, unless it's a problem for that particular application, I'm not sure why you would need to worry, right? If you're, for instance, if you have an inclined slab and you're putting a slump of concrete of 150 plus, that's not good because concrete will simply subside. But in most other cases, if your slump is slightly higher, without the addition of water, that is, then I really don't think there's need to provide a remedy to this concrete.
So here I have one question. We are facing a lot of the issue when we meet high slump at site.
Yeah.
Then we are facing a lot of the issue from our consultant. If we, as a design slump at 150 mm, if we found at site 170 or 175, then they will issue regarding slump. So what we take precautions?
So again, see, as I said, no, it depends really on the application. For instance, if you're filling up a beam formwork with the concrete, right? In such a case, having a high slump is not going to do you any harm if that's what the concrete is designed for. Now, if the slump is suddenly increasing, that may be an indication that you may have more water in the system. Or if it's suddenly increasing, that may some indication that you may have slightly increased the dosage of the admixture and so on. So all that you need to be aware. Okay. So yeah, I mean, follow-up question by Magadeshwaran is more slump is causing retardation problems. No, see, more slump is not causing retardation problems. Why you get that higher slump? Maybe because you've added additional admixture and that is causing retardation. A concrete that slumps more does not need to retard. Okay. It may be because of the admixture content being higher than what is actually there in the system. So that may have caused the retardation to happen. Yes, clients may feel that, okay, what have you done to the concrete that the slump is higher? But then again, you ought to have a correct answer for them that, yes, this admixture is more effective. Sometimes when the cement batch changes or aggregate batch changes, you may actually end up getting more slump also. So slump is a minimum requirement, not maximum requirement, unless you're coming with specific applications like an inclined slab and so on. Yes, but if it's related to an admixture overdose, then you have a problem.
Sir, I have a question apart from this course.
Yeah.
Is it so, sir? What is the minimum gate score required for BTC to get admission BTCM at IIT Madras?
Okay. For MTech program.
Yes, sir, for MTech BTCM course.
I'm not aware of the correct numbers, but if you are, I believe if you're more than 700 index score in gate, I think that should be good. 700 to 750, I think. If I'm not very, very certain myself, but yes.
Okay, sir. Thank you.
Sir, is there any upcoming course coming from IIT Madras, like this admixture and special concrete like thing? Like,
well, I think so. See, previously we were offering advanced concrete technology. That may get offered again next year, I think, next semester.
After 6 months?
No, starting January. Starting January.
Okay, I will be attending, sir.
Yeah. So that's advanced concrete technology. Some of you may have already taken it. This is.
No, I have not taken, sir.
Okay. Okay.
I will be taking, sir.
Yeah, that's a more broader course as compared to this one.
How long, sir, it is? 6 months?
No. Broader implying in terms of the subject content. So here, see what we essentially did was we took this advanced concrete technology and a part of that which dealt with admixtures, I took out and created a new course where I could add content on special concretes. So that was the purpose of this course, which is currently running. But the original course from which it has been taken out to some extent is the advanced concrete technology course that has a lot more content in terms of cement chemistry, in terms of admixtures, in terms of mix design, in terms of durability. All of those contents are there in the advanced concrete technology course.
Yes.
Sir, I have
We are-
another.
Sorry?
Sorry to bother to
Yeah.
you, sir. I have another question.
Yeah.
Sir, we are using PC-based admixture. So we may know, sir, what is the effect on strength in percentage, particularly admixture?
No,
on
which admixture?
PC-based.
No, see again, admixtures like PCE, SNF, they are not expected to alter your strength. For that water cement ratio, if you got a particular strength without admixture, you should be able to get the same with admixture. For the same water cement ratio, same cement content, same mix design. Except that you'll see an increase in workability. You should not see a major change in your strength. But you may get a marginal enhancement of 5 to 10% as compared to regular concrete without admixture. It may happen, but you don't require it. It's not necessary for that to happen.
Yes, sir. Yes, sir. So we may consider 5 to 10%. It will be effect on strength.
No,
When we add-
positive effect. Positive effect.
Thank you.
Yeah. There's a couple of questions in the chat box, and then I'll close this session. We are not able to procure calcined clay procured from low-grade clay or even LC2, LC3 Tara for research work. Hence, we have collected some low-grade kaolitic clay for trial CC production in our lab. Please suggest range of temperature and residence time for trial production so that we can limit it to minimum trials. Okay, good question. Residence time obviously will depend on the efficiency of your the calciner, but the temperature typically that you'll use is 750 to 800 degrees Celsius. Yeah, don't go more than 800 or don't go much higher than 800 because that will lead to recrystallization. So 750 to 800 would be good. But make sure that your clay is of the right type. When you say low-grade kaolitic clay, make sure that the kaolinite content is at least around 40 to 60% for it to produce a very good LC3 type system. Is there any chance for course structural health monitoring? Well, hopefully, I'm not very sure. Somebody should be offering it. I think there is already something on NPTEL with respect to that. You may do a search in the list of courses in NPTEL and see. Also, please suggest on characterization of clays, determination of quality of calcined clay. All this is very well explained in the annexures to the IS standard on limestone calcined clay cement. Okay, if you pick up the BIS, I forget the name number 18 something on limestone calcined clay cement. This is properly explained how to determine quality, how to characterize the clay, and so on. For leaching problem to curing, how much calcium and sodium can be added to water? Well, that's again that you'd be doing in a laboratory environment. So generally, when you want to add calcium, you add to a saturation level. That means you add calcium hydroxide to your water so much that it starts depositing. It does not dissolve anymore. That means you have saturated the system with calcium hydroxide. Yeah, IS 18189. I think that's correct. Yeah. Kumar, is it possible to take any online session on paper writing in concrete technology? I don't know. Online session on paper writing in concrete technology specifically, I'm not sure, but I'm sure that there are online courses on technical paper writing that you can take from NPTEL. Will there be another doubt clearance sessions before the exam? Exam is on 28th. So that is less than 3 weeks away. If needed, we can do a doubt session just before the exam. Would you need it?
Sir, yes, sir. Actually, still week 12 has not been completed, sir. If any doubt in week 12 and week 11, it could be solved. Because while revising, there will be other doubts coming from previous lectures also. Sir.
We can do it then. We can do it. I don't have a problem. No problem.
Okay, sir. Thank you, sir.
We'll certainly do it just 2 or 3 days before the exam. Okay.
Thank you, sir. Thanks.
Okay. Okay. Thank you all. We'll close with that then. Thank you.
Sir, there is one query in the chat box. That's the last one from the
range of pH value to be maintained in Keurig tank to avoid leaching. See, again, highly alkaline pH. So we're talking about when you saturate the water with calcium hydroxide, your pH automatically goes to 12.5 or so. Does leaching affect strength and durability of concrete? See, it'll affect the quality of the concrete cubes that you are getting out of your curing system, because it's not reflecting the actual conditions, but it's not going to majorly affect the result that much. But if you in research, it's always important to take care of that effect. In practice, it's not going to majorly affect your result in terms of the strength that you get out of the cubes. Your actual structure may be completely different. Leaching of water, leaching of material from your actual structure, that is not a desired thing. But here we are talking only about the cubes that are used for strength testing. So there the result will not be affected significantly. Okay. For maintenance of pH, how much for a volume of water, how much calcium hydroxide needed? As I said, you need to add more calcium hydroxide than the solubility limit. So I forget the number correctly. So you add sufficient lime so that all of it, whatever can dissolve, dissolves. Excess simply goes and settles at the bottom. But in a curing tank, again, yeah, I mean, unless you're doing research, you don't have to worry. For a field practice, normal curing in ordinary water is also not a problem. You can just put a little bit of lime if you want. It's not really a big deal. Did any IS code covers curing tank parameters? I really don't know very well about that, but just check. I'm not sure. Okay, so with that, we'll stop for today. Thank you all very much. I'll meet you again in the week of October 24th, I think 23rd, October 23rd. So 25, 26, 27, that is Wednesday, Thursday, Friday. One of those days we can arrange for a online session.